us try another example to solve differential equations by using the integrating factors. We are given these equations and the boundary conditions is this. Write down the differential equations, rearrange it in this format for you to identify the P and Q in these questions. This function here is not between dy and dx. In fact, it is between dy and d theta. To rearrange this in this format, you need to move this y to the other side, which gives you this. Compare the structure here. You will know that the P is actually equals to negative tangent theta, and Q is equals to secant theta. Now you need to integrate the P over d theta. Substitute this into the function here, you will get this. From the list of the formulas of integrations, integrating tangent x, it will give you this. That gives you integrations of tangent x equals to ln secant. Move this negative as the power of the secant theta. You will get 1 per secant theta, which can be rewrite into a cos theta. Now you produce the integrating factors by using these functions. Substituting this into the function here, you will get this, which eventually leads to cos theta. The e and ln here will cancel out each other, which is left over, it will be the cos theta. Now you need to substitute the integrating factors into the formula here. Substitute this from the function here, which is cos theta, and there will be a q in the formula, which is the secant theta. This gives you a new function here, and you know that secant theta is equals to 1 per cos theta. This will eventually be cancelled out. That leads to integrations of 1 d theta. After integrations, you get this. It is given that your boundary conditions is equals to y equals to 1 and theta equals to 0. Substitute the relevant value into the function here, and you will obtain c is equals to 1. You know that cos 0 will be equals to 1. Based on the c that you obtain, substitute back into the equation here, you get this. Rearrange the functions, and eventually this will be your solution. 1 per cos theta is actually the secant theta. Let us try another examples on the integrating factor. You are asked to find the solutions for the differential equation here. Given the boundary conditions is this. Write down the functions given in the question here. Rearrange it into this format so that you are able to identify the P and Q. This can be done by dividing the entire function here with the x minus 2. That gives you this function. Compare the structures of this function here. You know that P is equals to this, while Q is equals to this, as given here. Now you need to integrate the P here, which gives you this. This looks like integrating a partial fractions problems. You will need to expand it into partial fractions, where you have a divided by x minus 2 plus b divided by x plus 1. Combine the two partial fractions, you get this, and equate this with this. From here, you know a plus b equals to 3, and a minus 2b will equals to negative 3, as written here. Solve the two equations simultaneously, you get a equals to 1, b equals to 2. With that, integrating this can be rewritten in the format of this as obtained here based on the partial fraction. Integrating this will give you the solution here. Move these two into the power of the functions. The relationship is plus. That means once you combine, they become in the form of multiplications. This will be the outcome of the integrated p over dx. Next, you need to produce the integrating factors by using this. Integrations p over dx is actually this. You may substitute into the equations which give you this. The e and long will cancel out each other. What is left over, it will be the outcome of the integrating factors. Now you need to substitute the integrating factor here into the function here. Substituting this into here, and there is a q in the formula. The q is actually obtained from here, which you may substitute inside, and you will obtain this. Simplify the function here, you will obtain this. Integrate this, you will get this, and there will be a constant c. The boundary conditions is given here, which you're going to substitute this into the function here as the y and x, and you will get c equals to 0. Substitute c equals to 0 into the function here. This will be your general solutions. Rearrange the equations, and this will be your final solution.